In this video, we're going to try and integrate cosecant of x. So if you have a circle of radius 1, let's say this here has a radius of 1, then this length here is sine theta, and this here is 1. So cosecant is 1 over sine theta. So cosecant can be written as 1 over sine theta. So once you're here, times top and bottom by sine x. So times top and bottom by sine x. So this thing here will become this, and then sine squared. Remember this? 1 equals sine squared of x plus cos squared of x. So we can rearrange this and then put it into here. So this thing here becomes this. So we are currently here. And then now use substitution. So let u equals cos. So du equals this thing here dx. So we ultimately want to replace this dx here. So rearrange this to make dx a subject. So dx equals this thing here. So we can now put this into here, and we can put the u into here. And then later on, if you look at dx, there's a sine x at the bottom. That will later on kill this thing off. Well, anyway, once you are here, put the u into here, put this into the dx here. This whole thing here will then take you to here. And then now your sine x will cancel out, leaving you with this. Okay, so now times top and bottom by minus 1. So this whole thing here will then become this. So now it's just a matter of integrating this, and we've done this. Remember the section on partial fractions? We need to break this up into 2 separate fractions. In order for us to integrate this, we need to break it up into 2 separate fractions. So if you look at this, remember I've always told you in the past, always try and keep an eye out for something where this thing is easily square rootable, and there happens to be a minus in between. Then you can jump to u plus 1 and then u minus 1. So keep an eye out for something easily square rootable, and there happens to be a minus in between. Then you can jump to here. So this thing here can be written as this. So now this here is our ultimate aim. We are trying to integrate this, but first we need to break it up into 2 separate fractions. So now it's just a matter of finding a and b in such a way that this thing will be exactly the same as these 2 fractions. Okay, so we're going to set this to be so from here and here, that will then take us to here. So we are really trying to search for a and b in such a way that this whole thing will be the same as this whole thing here. So now it's just a matter of finding out a and b. So once you're here, and we've done all this under the section of partial fractions. So hang on, let me think. So we are trying to find a and b. So once you're here, times top and bottom times. So currently you've got this thing equals this thing equals this thing, times everything by u plus 1. Then if you times everything by u plus 1, this fraction here, if you times by u plus 1 times by u, hang on, let me think. Hang on, times everything by u plus 1. Yeah. So sorry. Once you're here, you've got this thing equals this thing and this thing, times everything by u plus 1. If you times this by u plus 1 times by u plus 1 here, and then times this by u plus 1, then this u plus 1 will cancel out with this u, so these two will kill off each other, just leaving you with this. These two will kill off each other, leaving you with a, and this whole thing here will take you to here. Now let u be minus 1, then a must be, we've done this many times, okay, so hopefully you could follow that. So now we know a, we know a equals -1/2, Now we need to find b. So so use the same technique, but this time let u be -1. So sorry, let u be 1, and then b will be a half. So now we know a and we know b. So back to this thing here. We know a is -1/2. We know b is a half. So now factor out the half. That will then give you this, and then switch these two fractions around. So that will take you to here, just to tidy it up. And then now integrate this and integrate this. That will then give you the natural log of this and this. So integrate this, it will give you this. Integrate this, it will then give you this. Okay. So now when you're here, just know that when you natural log of a over b equals natural log of a take away natural log of b. So here we've got a case where we've got natural log of one thing take away the natural log of another thing. Here we've got the natural log of one thing take away the natural log of another thing. So we are currently here, so you can work backwards and jump back to here. So from here, that will then take us to here. Now if you let u earlier we said let u be this thing here. So this is our answer, but we don't want the answer in terms of u. So earlier we said let u be cos of x. So we can now put cos of x back into the u and then back into the u. That will then take us to here. So now that we're here, hang on. Now that we're here, then times top and bottom by the numerator here. So times top and bottom by the numerator. So times top and bottom by this and by this, and then the numerator will then become this, because if you look at this, exactly the same times exactly the same. So it must be exactly the same squared. And then down here, you've got this plus here, and then the conjugate here, which is minus here. So remember that when you multiply this out, the two middle terms will cancel each other out, leaving you with this. So currently, earlier we were here times top and bottom by the numerator. That would then take us to here. Okay, so now that we're here, hang on, bear with me. Now that we're here, let me think. Now that we're here, we want to replace this with sine squared. But remember, sine squared, if you look at this, 1 equals sine squared theta plus cos squared theta. Rearrange this, so 1 minus cos squared theta equals sine squared theta. You see, if you look at this here, this is almost the same as this. The only thing is it's a negative version of this, is a negative version of this. We want to obtain this, but at the moment this is very close to this. So the way we make this adjustment is to rewrite this as -1 times 1 minus. Here you've got this thing minus 1, but now down here you've got you've got 1 minus this thing here. So rewrite as this. Now if you tidy this thing up, now if we tidy this thing up, if you have AB, the absolute value of AB, then that's the same as absolute value of A times absolute of B. If you have the absolute value of A over B, then that's the same as absolute value of A divided by absolute value of B. So when you are here, you can jump to here, because if you look at this here, let's just imagine this as a complicated bubble. So here you've got a complicated bubble over -1 here, which is this bit here, and then you've got another complicated bubble here, and then you've got an absolute value here. So now using this, we can jump to here. We can jump to here. So this will be like this: complicated absolute value of that divided by, and then the absolute value of -1, and then complicated, and then close of the absolute value. And now we can use this. When you have two things multiplying with each other, you can jump to here. So hang on. So if you look at this bit here, you've got one thing multiplying with another thing. So you can actually jump to this absolute complicated, and then you can actually do this absolute value of -1, and then absolute value of that complicated thing here. Now the absolute value of -1 is just 1. So we can pretty much forget about this. So well, think about it. From here you can hang on. From here you can actually jump to this. Think about it. Use this. You can jump to here. So once you're here, hang on. Once you are here, we can now replace this with sine squared. So that will then take us to here, and then once you're here, hang on. Once you're here, hang on. Let me think. Hang on. Let me think. Once you're here, you can somehow get to here. Okay, and then somehow from here, this, yeah. So once you're here, I don't know how I got from here to here, but think about it. Okay, I can't think on the spot. So once you are here, you've got this thing times this thing, and then you square it. So you've got -1 times this thing times -1 times this thing here. You can merge the two -1s together. So this will pretty much disappear when you come to square this times this. This here will disappear. So from here, that will then take you to here. And then if you look at this, you've got something times by itself, and then here you've got sine squared times by itself. So you can rewrite this as this. So you can rewrite it as this squared, because if you have like a squared over b squared, that's the same as a over b times a over b. That's the same as this, really. Okay, well, anyway, from here, that will then take you to here, and then when you natural log or an index, when you have something to the power and you natural log it, you can take the 2 out. So this whole thing here will then become this. These two will cancel each other out, giving you these two will cancel each other out, and then break this up. So it's one fraction, take away another fraction. So this thing here is this thing here is cosecant, and then this thing here is cotangent. Okay, so remember, tan is here, so going the opposite way would be cotangent. So this here is your overall answer. Okay.